Reflection is a useful tool in some applications. Reflection drives data binding, model binding, data annotations, and a number of other useful features in different Microsoft frameworks. And if you've ever written any reflection code yourself, you'll know just how powerful it can be. I rarely write an application today that doesn't have some amount of reflection inside. I want to demonstrate a few features with a focus on how generics play with reflection. We'll need a new project for this module, so let me create a console mode application, and we can call it Reflect It. And inside of here, just inside of program.cs, I'll create a new class, a class we've used before, the good old employee class. Every employee has a name. And now what I'd like to do is create a list of employee. So employee list equals a new list of employee. But creating a list of employee using the new operator is a little too easy. What I'd like to do instead is use some other method that will create a list for me just by allowing me to specify the type of list that I want to create. So I want to create type of list employee. The type of operator will give me back a system.type reference. And I'll use Visual Studio to generate this method, perhaps rename it as create collection. I don't know the exact type of object I'm going to create that's specified by the type, but I do plan on this only creating collections. And it turns out this is very easy to do. There is a class in the system namespace called Activator, and Activator has a create instance method where you give that method a type, and it will go out and create that object for me. Now that does assume that the type has a default parameterless constructor, but that's a topic we'll return to later. But just to see if this can work, let's write the name of the type that we get back from create collection. So I run the application, and I see list backtick 1. There's two notable pieces of information about this output. First, list backtick 1 looks like someone mangled the name list of t, but in fact this is what the C# compiler has to produce as a type name to be compliant with the Common Language System, the CLS. The CLS is the specification which allows all the different languages like C#, Visual Basic, and F# to work together. The number here, 1, is the arity of the generic type, which is a fancy way of saying that this type requires one generic type parameter. If we created a dictionary of t key and t value, we'd see backtick 2 because the dictionary requires two generic type parameters. You might have to use this syntax if you ever specify types in a web.config or an app.config file. Since config files are used by all languages on the .NET runtime, the way you specify generic types is with this CLS compliant name. The other thing to note is that there is no mention of employee in this particular output. Now, if I did getType.fullName instead of just getType.name, then fullName would actually put together the type of the collection with the generic parameters. So getType.fullName, run this real quick, and you'll see name is just list backtick 1, but the full name, including namespaces and assemblies, is list backtick 1, and then in brackets, the employee type that is used. So there is information inside of this metadata object, the system.type reference, that knows we constructed this list using employee, and we can use the reflection API to dig that out and clean up this output a little bit. Let me just write out getType.name, then find the generic arguments that were used on this type by saying employee list, we'll get the type again, and get the generic type arguments. Notice that's plural because a type could certainly have more than one generic type argument. So now I can create a loop that says for each argument in the generic arguments collection, let's console.write bracket parameter 0 and pass into that argument.name. This is also a type object. So generic type arguments will return an array of type information. And then at the bottom here, I can do a console.write line. And now if I run the program, you can see I've put the two pieces of information together to say that yes, this is a list of employee. So even though we think about list of employee as a single type, it is, at some lower level, really the combination of a generic type and a generic type argument. And those two pieces of information put together form what is known as a closed constructed type. A closed constructed type is something that you can instantiate, like list of employee, list event, list of double. But what if I wanted to detach these two pieces of information in my create call? In other words, what if I wanted create collection to take two parameters? One parameter tells me the collection type, and another parameter, type parameter, tells me the item type to store inside. And this is just going to assume that we're always creating a collection that just needs a single generic argument. For right now, I'll have Activator try to instantiate the collection type directly. I'm just trying to add some flexibility because now the information can come from two different parties. One party can tell me the type of collection it needs, be it list or hash set or sorted list, and then the actual item that will be stored inside, that can come from a second party, whether they want it to be double or employee or date time. And up here, when I call create collection, it's very easy to figure out how to pass the employee type or the item type that I want. But what do I use when I want to specify the type of collection that I want? What do I put in here? Do I put in list of T? Because I don't want to specify employee here, I want that information separate. And the answer is no. If I put a T in there, the C# compiler goes off looking for a generic parameter named T, but there are no generic parameters either on this class or on this method. So the answer is I actually leave this off. I leave out the generic parameters, and I just have brackets. This is what we call an unbound generic. And I can only use this syntax in a type of operator because an unbound generic can never exist as an instantiated object, only as a system.type reference that represents the unbound generic. It's impossible to instantiate this. I can demonstrate that if I try to run the program, and we have activator.createInstance try to create that collection type. You'll notice the exception says it cannot create this because this type contains generic type parameters. It's telling me that it needs some generic type arguments to transform this unbound type into a closed constructed type. So let's try that. Before I do that, I will point out that if I needed multiple type parameters here, I could use commas. So if list took 3 type parameters for whatever reason, then 2 commas would be a way of saying we need 1, 2, 3 type parameters. But a list just needs 1. So this is the proper syntax to use. And inside of create collection, I have a little more work to do. So I'm assuming that the collection type is unbound. I need to transform it into a closed type. And I can do that by taking the collection type and invoking a method makeGenericType. With makeGenericType, I pass in any type arguments that that generic type needs to become a closed constructed type. In this case, we assume that we only need 1 type argument, so I'm just going to pass in the 1 parameter item type, and that should work for list and hash set and stack and queue and all the things that only need a single parameter. It won't work for dictionary, that requires 2 parameters. But now I don't want to create an instance on collection type, I want to create an instance on this closed type. And now let me run the program again. And we're back to constructing a list of employee. So all this information will become useful later when we start looking at building an IOC container. But for now, you can see that generics add a little more complexity to reflection, depending on what you want to do. But the API to support all the reflection work is there. We can inspect generic types, instantiate generic types. We can do anything that we need to do with generic types, and we'll see more of that later. Another job that we sometimes do with reflection is to invoke properties and methods. So how does reflection work with generic methods? So let's look at that next.